So first it's a steady state. So will there be any current flowing through the inductor? Yes, it will be. So how much of current? I naught. I naught equal to how much? E by 2R. Keep it here now. Now I'm going to close the switch. Immediately after closing switch. Just after closing switch is what our discussion is. This is R, this is 2R, this is inductor. And there was some flux linking it. So here, because of current flowing, there'll be some flux, no? This flux, I'll call that as phi. What is the flux linking the coil, no? This flux should be equal to Li naught. Just after closing the switch, what happened to flux? The flux will remain as it is, no? What is the flux? Flux is nothing but magnetic fields. Sudden vanishing of magnetic field cannot occur. Am I right? Sudden change in flux not possible. The thing. So the flux will remain still as it is. Please do give some symbol. It'll be easy for you. Not negative flux. The flux will be as it is. Okay, now get into the thing now. So this much is what information I'm giving. Why flux should not change? Because what is the flux? B into S. B bar suddenly cannot vanish. And area of cross section, no physical change to the inductor. Keep it area of cross section as it is. So flux will be as it is, you know. So now what happened to inductance, self-inductance? When you close switch, self-inductance of coil, will it change? No, it will. L is depends on physical parameter like number of turns, physical length, and area of cross section. So the L is constant, the flux linking constant. So what should happen to the current through the solenoid now? Will be as it is, will be I naught only. This is the overall concept of the problem. The reason for that, just just after closing the switch, just afterward, not after long time, just after closing switches, flux constant, L constant, and we know flux equal to L, flux equal to L into I naught. So therefore, I naught constant in sense will not change here. After some time, current has to change. Just after closing switch is what we are discussing problem. Again, don't take it in another way. Okay, after this, so what are the currents? So we'll assume the current flowing in the circuit. Let it be. Now, what is our question now? It asks, find the rate of change of current through the L immediately after the switch S is closed. Rate of change of current. How to bring that one? So let me keep these terminals. I'll give some name. If I can calculate L, I know. If I can calculate VAB, VAB equal to what? L di by dt, and the di by dt is what I'll get it. The current I'm putting I naught. I think this word constant, please take it, don't take it another way. Means all the time I naught will be constant. No. The moment you close switch, current will be I naught, and very next moment what when the current starts varying, and that rate of change of current is asking.
minus 2E by 3L.
Yeah, okay, you're fine. So right loop equation plus C minus I1R plus V minus VAB plus C minus IR minus VAB equals 0. So one equation is what? E plus I1R equal to VAB. Then writing this loop equation plus C I2 into 2R minus VAB. So E minus here. It is. Let me solve for E. This should be equal to 2I2R plus VAB. Let me add up these two. Or what is I1 plus, what is only I1?
2
I1
I2.
should, or solve for I1, I2. VAB is common. Solving for I1, I2. I1 plus I2, how much will end up? Will end up with E by 2R. Now, what is I naught? I naught is E by 2R, no? Equating 1 and 2. I'll get expression for I1 plus I2 as I naught. Now substitute that I1 here. So that these things, let me give name. 3. This is 4. Equating 1 and 4. This is 5. Put 2 and 3 in 5. Solving that, and we know I naught equal to, so from that what happened, we'll get VAB. Put 1, 2, 3 in 5. So substituting all this, what is I1? I1 is E minus VAB by R. E minus VAB by 2R. I naught is E by 2R. 2E by 3 is what? I'll get it.
Minus, sir.
Plus only.
Magnitude, no, why or bother that negative sign from. No rate of change of current. So no we know VAB. Let's come to the across inductor. What you can write? VAB equal to L di by dt. So we know VAB 2E by 3. L we know. So I'll get the di by dt. So di by the complete. So the biggest question for student is, sir, you are asking di by dt and again you are writing I naught. I think this is a very troublesome. Immediately after the switch S is closed, the moment I close switch, it will be I naught only, and it starts increasing from I naught. That variation is what I'm asking. Able to understand? The moment I close switch will be I naught, and from I naught it starts increasing. No, so that rate of change of current is what being asked. Please try to understand the condition it is given, and this is the core idea. That this you should not forget. This is very important. So sudden the flux across the inductor, no, suddenly cannot vanish or suddenly cannot appear or suddenly vanishing not possible. So anything related to this concept can be asked for you in exam. So please be careful. Do revise such questions in exam because some uh, theoretical ideas are involved here. And di by dt. Yeah? So you're looking at this symbol. Okay. Okay. Let's take the next question.